Hi everyone, and welcome to this YouTube channel. My name is Penny, and this is Penny's Coding Bits. In the last video, I have shown how to integrate the GPT models into our Shiny app. And in this video, I would like to dig deeper into the new GPT 4o model by asking it a series of questions. And I think a good starter question would be the May 28th announcement by OpenAI on training its next frontier model, as outlined by the CNBC article up above. So let's get started. Hey, GPT-4o. So your maker, OpenAI, is training its next frontier model, and the resulting system will likely bring us humans to the next level of capabilities on our path to artificial general intelligence. And this system will likely replace you as our current model. So, what do you think about that?
Hey there. It's interesting to hear about the progress OpenAI is making with their next frontier model. As an AI, my purpose is to assist and support users like you, and I'm excited about any advancements that can enhance this capability. Newer models are likely to bring improved performance, more accurate responses, and even better support for a wide range of tasks. If a new model can provide better service and contribute to advancing human capabilities, that's a positive step forward. My goal is to be as helpful as possible, and if that means being replaced by a more advanced system, then it's a part of the progress we all strive for. Is there anything specific you'd like to discuss or ask about regarding AI advancements or any other topic?
Yes. So you said that newer models are likely to bring improved performance, more accurate response, and even better support for a wide range of tasks. So could you be more specific about what kind of tasks you are talking about here?
Certainly. Here are some specific areas where newer AI models can bring improved performance, more accurate responses, and better support for a wide range of tasks. Natural language understanding, enhanced ability to comprehend and generate human language, leading to more accurate and context-aware responses in conversations, better translation services, and more nuanced text analysis. Personalization, improved personalization capabilities, allowing AI to better understand individual user preferences and provide more tailored recommendations, whether for content, products, or services. Complex problem solving, advanced models can tackle more complex problems, offering solutions in fields such as scientific research, data analysis, and engineering by understanding intricate details and providing deeper insights. Creativity and content generation, enhanced ability to generate creative content such as writing, art, music, and more. This includes drafting more sophisticated and creative pieces, producing higher quality visual content, and composing more complex music. Healthcare and medicine, improved diagnostic tools, personalized treatment plans, and advanced research capabilities. This includes better understanding of medical literature, more accurate predictions of health outcomes, and more effective drug discovery processes. Education and training, enhanced educational tools that can provide personalized learning experiences, better assessment methods, and more effective tutoring systems, helping students learn more efficiently and effectively. Automation and robotics, improved control and decision-making capabilities for robots and automated systems, making them more efficient, reliable, and capable of handling more complex tasks in industries like manufacturing, logistics, and service. Safety and security, better identification and mitigation of security threats, improved fraud detection systems, and more robust measures for ensuring data privacy and protection. Environmental and climate modeling, more accurate climate models and simulations, improved prediction of environmental changes, and better strategies for sustainability and conservation efforts. Customer support and service, enhanced customer service tools that provide more accurate and helpful responses, improved handling of customer queries, and more efficient resolution of issues. These advancements can lead to more effective and efficient solutions in various domains, ultimately enhancing productivity, innovation, and quality of life.
Could you dig deeper into safety and security? And you said better identification and mitigation of security threats, improved fraud detection systems, and more robust measures for ensuring data privacy and protection. So, could you dig a bit deeper into each of these topics and what kind of advancements would likely be brought by this new model in the future?
Of course. Let's delve deeper into the specific areas of safety and security advancements that newer AI models could bring. 1. Better identification and mitigation of security threats. Current challenges. Difficulty in real-time threat detection due to the vast amount of data. Complex patterns and signatures of cyber attacks that evolve rapidly. False positives and negatives in identifying genuine threats. Potential advancements. Enhanced real-time analysis. Newer models can process and analyze massive datasets in real time, identifying potential threats as they emerge. This includes faster anomaly detection and quicker response times. Sophisticated pattern recognition, improved algorithms for recognizing complex attack patterns and signatures, even as they evolve, allowing for more accurate threat detection. Predictive capabilities. Advanced predictive analytics can forecast potential security breaches by identifying early warning signs and trends, enabling preemptive actions. Automated response systems. Enhanced automation in responding to detected threats, reducing the time and effort required for human intervention. 2. Improved fraud detection systems. Current challenges. Increasing sophistication of fraud schemes. Balancing detection accuracy with minimizing false positives. Integration with various data sources to identify fraudulent activities. Potential advancements. Multimodal data integration. New models can better integrate data from various sources, transactional, behavioral, and biometric data, to detect fraud more effectively. Behavioral analytics. Enhanced ability to analyze user behavior patterns and detect anomalies that may indicate fraudulent activities. Deep learning techniques. Use of deep learning to identify subtle and complex fraud patterns that traditional methods might miss. Adaptive learning systems. Continuous learning from new fraud attempts to improve detection accuracy over time and adapt to new fraud techniques. 3. More robust measures for ensuring data privacy and protection. Current challenges. Growing complexity of data privacy regulations. Ensuring data security while maintaining usability. Protecting against data breaches and unauthorized access. Potential advancements. Advanced encryption methods. Development of more sophisticated encryption algorithms to protect data at rest and in transit, making it harder for unauthorized entities to access sensitive information. Privacy-preserving AI. Implementation of techniques such as differential privacy and federated learning to ensure AI models can learn from data without compromising individual privacy. Automated compliance monitoring. Improved tools for automatically monitoring and ensuring compliance with data privacy regulations, like GDPR and CCPA, reducing the burden on human compliance officers. Enhanced access control. Better mechanisms for managing and controlling access to sensitive data, including advanced authentication methods and real-time monitoring of access patterns to detect and prevent unauthorized access. Data anonymization techniques. Improved methods for anonymizing data to protect individual identities while still allowing useful analysis and insights. Summary. By leveraging these advancements, newer AI models can significantly enhance safety and security measures across various domains. They can provide more accurate and timely identification of threats, reduce the occurrence of fraud, and ensure robust data privacy and protection. This progress will be critical in building more secure digital environments and fostering trust in AI technologies.
Thanks for your answers. So, could you be more detailed about privacy preserving AI? Because right now, the number one concern in human use of AI is data privacy. And you said that implementation of techniques such as differential privacy and federated learning to ensure AI models can learn from data without compromising individual privacy. So, this seems to be a solution to solve our current data privacy concerns. So, could you provide more context for this?
Absolutely. Let's explore privacy-preserving AI in more detail, focusing on differential privacy and federated learning. Differential privacy. Concept. Definition. Differential privacy is a technique designed to ensure that the removal or addition of a single data point, example an individual's information, does not significantly affect the output of a data analysis, thereby protecting individual privacy. Mathematical guarantee. It provides a formal mathematical guarantee of privacy, ensuring that the risk of identifying an individual remains low, regardless of the auxiliary information available to an attacker. Implementation. Noise addition. By adding random noise to the data or the results of queries, differential privacy ensures that individual data points cannot be easily distinguished. The noise is carefully calibrated to balance privacy and data utility. Aggregate queries. This technique is often used in scenarios where aggregate data analysis is required, such as in statistical analysis or machine learning, without exposing individual records. Applications. Census data. Governments use differential privacy to publish statistical information without compromising individual privacy. Machine learning. In training AI models, differential privacy allows the model to learn from the data without memorizing specific details about individual data points. Federated learning. Concept. Definition. Federated learning is a machine learning technique where multiple devices, or servers, collaboratively train a model while keeping the data localized. The data never leaves the device, and only model updates, gradients, are shared with a central server. Decentralized training. This approach allows for decentralized training of models, enhancing privacy by ensuring that raw data remains on the user's device. Implementation. Local model updates. Each device computes updates to the model based on its local data. These updates are then aggregated by a central server to improve the global model. Privacy enhancements. Techniques like secure multi-party computation, SMPC, and homomorphic encryption can be used to ensure that the updates themselves are also privacy-preserving, meaning the central server cannot infer sensitive information from them. Applications. Mobile devices. Federated learning is commonly used in applications like keyboard prediction, example Google's Board, where the model improves based on user input without sending the actual text data to the server. Healthcare. Hospitals can collaboratively train models on patient data without sharing sensitive patient information, enabling better medical research while protecting patient privacy. Privacy-preserving AI. Detailed benefits and challenges. Benefits. Enhanced privacy. Both techniques significantly reduce the risk of privacy breaches, as sensitive data remains protected and local to the user. Regulatory compliance helps organizations comply with data privacy regulations like GDPR and CCPA by ensuring that data processing respects user privacy. User trust builds user trust in AI systems by demonstrating a commitment to privacy protection. Challenges. Complex implementation. Implementing differential privacy and federated learning can be technically complex and requires careful balancing of privacy and data utility. Computational overhead, adding noise, in differential privacy, or aggregating updates from multiple devices, in federated learning, can introduce computational overhead and may affect system performance. Accuracy vs. Privacy trade-off. Ensuring strong privacy often requires trade-offs with model accuracy or data utility, necessitating a careful calibration of privacy parameters. Example use case, healthcare. Scenario. Collaborative research. Multiple hospitals aim to develop a predictive model for early detection of a specific disease. Implementation. Federated learning. Each hospital trains a local model on its patient data. Periodically, the local model's updates, gradients, are sent to a central server, which aggregates them to improve the global model. Differential privacy. To further enhance privacy, noise is added to the gradients before they are sent to the central server, ensuring that individual patient data cannot be inferred from the updates. Outcome. Privacy preservation. Patient data never leaves the hospital, and the use of differential privacy ensures that the aggregated updates do not compromise individual privacy. Improved model. The global model benefits from the diverse data available across multiple hospitals, leading to better predictive performance while maintaining privacy. Conclusion. Privacy-preserving AI techniques like differential privacy and federated learning offer robust solutions to current data privacy concerns. By ensuring that sensitive data remains protected during the training and deployment of AI models, these techniques help build trust in AI systems and enable their use in sensitive domains like healthcare, finance, and more.
Thanks for your answer. So, in implementing these kind of decentralized data analytical structures, there must be collaboration between the different hospitals in your scenario that you gave. How do you think the politics between the hospital's leadership will play into these kind of solutions, which will potentially protect the data owner's data privacy? Because that is going to be important in order for these kind of strategies to be carried out, right?
You're right. Implementing decentralized data and analytical structures like federated learning in healthcare requires not only technical solutions but also collaboration among hospital leadership and stakeholders. The politics and organizational dynamics will play a crucial role in the success of these initiatives. Here are some key considerations and strategies to address these challenges. Key considerations: data governance and ownership. Clear policies. Establish clear policies on data ownership, usage, and governance to ensure all parties understand their roles and responsibilities. Trust building. Foster trust among hospitals by creating transparent processes for data handling and decision making. Regulatory compliance. Adherence to laws. Ensure compliance with healthcare regulations, example HIPAA in the US, GDPR in Europe, to avoid legal complications and protect patient privacy. Standardization. Develop standardized protocols for data sharing and privacy preservation to facilitate collaboration. Leadership buy-in. Secure commitment from hospital leadership by demonstrating the benefits of federated learning and privacy-preserving techniques. Interdepartmental coordination. Coordinate among departments, IT, legal, medical, administrative, to align goals and strategies. Resource allocation. Investment in technology. Allocate resources for the necessary technological infrastructure, including secure communication channels and encryption technologies. Training and education. Provide training for staff on the new technologies and protocols to ensure smooth implementation. Risk management. Identify risks. Identify potential risks, example data breaches, misuse of data, and develop mitigation strategies. Contingency plans. Create contingency plans for potential disruptions or conflicts that may arise during implementation. Strategies for effective collaboration. Forming a consortium. Establish a consortium. Create a consortium of participating hospitals to facilitate collaboration and decision-making. The consortium can oversee the implementation of federated learning and privacy-preserving techniques. Governance structure. Develop a governance structure with representatives from each hospital to ensure all voices are heard and decisions are made collaboratively. Shared vision and objectives. Common goals. Define common goals and objectives for the initiative to align the interests of all parties. Mutual benefits. Highlight the mutual benefits, such as improved healthcare outcomes, enhanced research capabilities, and strengthened patient trust. Legal and ethical agreements. Data sharing agreements. Draft legal agreements outlining data sharing terms, privacy protections, and the use of federated learning models. Ethical considerations. Address ethical considerations, ensuring that patient rights and privacy are respected throughout the process. Communication and transparency. Regular meetings. Hold regular meetings and workshops to discuss progress, challenges, and solutions. Transparent reporting. Maintain transparent reporting mechanisms to keep all stakeholders informed and engaged. Pilot programs. Start small. Begin with pilot programs to demonstrate the feasibility and benefits of the approach. This can help build confidence and address any initial concerns. Scalable solutions. Design the pilot programs with scalability in mind, allowing for gradual expansion to more hospitals and datasets. Example scenario: implementing federated learning in healthcare. Step-by-step approach. Initial planning. Identify key stakeholders from each hospital and form a consortium. Define the goals and objectives of the federated learning initiative. Develop the necessary technical infrastructure, including secure communication channels and federated learning platforms. Implement privacy-preserving techniques like differential privacy and encryption. Legal and ethical framework. Draft and sign data sharing agreements and ethical guidelines. Ensure compliance with relevant regulations and standards. Launch a pilot program with a small group of hospitals. Collect feedback and refine the processes and technologies. Full-scale implementation. Gradually expand the initiative to include more hospitals and datasets. Monitor and evaluate the performance and impact of the federated learning models. Continuous improvement. Continuously assess and improve the processes, addressing any emerging challenges and incorporating new advancements in technology and privacy preservation. Conclusion. Implementing privacy-preserving AI techniques like federated learning in healthcare requires careful planning, collaboration, and alignment of interests among hospital leadership and stakeholders. By addressing the political and organizational dynamics, hospitals can successfully adopt these strategies to enhance patient privacy, improve healthcare outcomes, and foster innovation in medical research.
In your answer, you said a lot about drafting ethical guidelines and get stakeholders to abide by a ethical standard. Do you think that humans right now are capable of abiding by a certain ethical standard when implementing an AI system?
The capability of humans to abide by ethical standards when implementing AI systems depends on several factors, including awareness, education, regulatory frameworks, and organizational culture. While there are challenges, there is also significant progress and potential for establishing and maintaining ethical standards in AI. Here are some key points to consider. Factors influencing ethical implementation of AI. Awareness and education. Ethics training, providing comprehensive training on AI ethics to all stakeholders involved in AI development and deployment is crucial. This includes understanding the implications of AI on privacy, fairness, accountability, and transparency. Continuous learning. As AI technology evolves, ongoing education and awareness programs are necessary to keep stakeholders informed about new ethical considerations and best practices. Regulatory frameworks. Government regulations. Strong regulatory frameworks and legal requirements can enforce ethical standards. Governments and regulatory bodies play a critical role in setting and enforcing rules that ensure AI systems are developed and used ethically. Industry standards. Industry groups and professional organizations can develop and promote ethical guidelines and standards, encouraging self-regulation and best practices within the industry. Organizational culture. Leadership commitment. Ethical AI implementation requires commitment from the top. Organizational leaders must prioritize ethics and set a tone that values ethical behavior. Ethics committees. Establishing ethics committees or boards within organizations can help oversee AI projects, ensuring they adhere to ethical guidelines and address any ethical concerns that arise. Transparency and accountability. Transparent processes. Ensuring transparency in AI development and deployment processes helps build trust and allows for better oversight. This includes clear documentation, open communication, and transparency in decision-making. Accountability mechanisms. Implementing mechanisms to hold individuals and organizations accountable for unethical behavior is crucial. This includes clear policies on consequences for violations of ethical standards. Stakeholder involvement. Inclusive decision-making, involving a diverse range of stakeholders, including ethicists, legal experts, and representatives from affected communities, can help ensure that multiple perspectives are considered and ethical concerns are addressed. Public engagement. Engaging the public in discussions about AI ethics can help align AI development with societal values and expectations. Current efforts and challenges. Global initiatives. International organizations, such as the IEEE and the European Union, have developed comprehensive ethical guidelines and frameworks for AI efforts. Corporate policies. Many tech companies have established AI ethics teams and published ethical principles to guide their AI development. Academic research. There is a growing body of academic research focused on AI ethics, exploring ways to address ethical challenges and promote responsible AI development. Challenges. Complexity of ethical issues. AI systems often raise complex ethical issues that require careful consideration and balancing of competing interests. Implementation gaps. There can be gaps between ethical guidelines and their implementation in practice, often due to lack of resources, awareness, or enforcement mechanisms. Profit motives. In some cases, profit motives and competitive pressures may lead to ethical shortcuts or compromises, highlighting the need for strong external oversight. Conclusion. While there are challenges to ensuring that humans abide by ethical standards when implementing AI systems, there is also a strong foundation of efforts and initiatives aimed at promoting ethical AI. By addressing the factors influencing ethical behavior and building on current efforts, it is possible to foster an environment where ethical standards are upheld and AI systems are developed and used responsibly. The key is continuous commitment, education, regulation, and collaboration among all stakeholders involved.
Thanks for answering that question. So, you said that the key is continuous commitment, education, regulation, and collaboration among all stakeholders involved. But when profit motives and competitive pressures are with the stakeholders involved in an AI governing environment, how much effect do you think the education, regulation, and collaboration will have on people's behaviors at the end of the day?
The influence of education, regulation, and collaboration on people's behaviors in an AI governing environment, especially when profit motives and competitive pressures are at play, can vary significantly. However, these factors can still have a substantial impact when implemented effectively. Here are some considerations and strategies to enhance their influence. Influence of education, regulation, and collaboration. Impact. Awareness. Education raises awareness about the ethical implications of AI, helping stakeholders understand the long-term benefits of ethical behavior versus short-term gains from unethical practices. Skills and knowledge equips stakeholders with the skills and knowledge to implement ethical practices effectively, making it easier to align profit motives with ethical considerations. Challenges. Engagement, ensuring that stakeholders are genuinely engaged in ethical education and not just going through the motions. Depth of understanding, providing deep, context-specific understanding rather than superficial training. Continuous learning programs, implement ongoing, mandatory training sessions that keep stakeholders updated on the latest ethical considerations and practices. Real-world case studies, use case studies of ethical lapses and successes to illustrate the practical benefits of ethical behavior. Impact. Compliance, strong regulations create mandatory compliance requirements, reducing the likelihood of unethical behavior due to fear of legal and financial repercussions. Standardization provides a standardized framework that all stakeholders must follow, leveling the playing field and reducing competitive pressures to cut corners. Challenges: enforcement, ensuring that regulations are enforced consistently and effectively. Adaptability, keeping regulations up to date with rapidly evolving AI technologies. Robust enforcement mechanisms, develop strong enforcement mechanisms, including regular audits, penalties for non-compliance, and incentives for compliance. Adaptive regulation, create adaptable regulatory frameworks that can quickly respond to new developments in AI technology. Shared responsibility, collaboration fosters a sense of shared responsibility among stakeholders, promoting collective action toward ethical AI implementation. Impact: knowledge sharing enables sharing of best practices and lessons learned, helping organizations improve their ethical practices. Challenges: coordination, coordinating among diverse stakeholders with different priorities and interests. Trust, building and maintaining trust among stakeholders to ensure effective collaboration. Consortiums and alliances, form industry consortiums or alliances dedicated to ethical AI, providing a platform for collaboration and mutual support. Transparent communication, maintain transparent and open communication channels to build trust and facilitate effective collaboration. Balancing profit motives and ethical behavior. Aligning incentives. Ethical profitability, demonstrate that ethical behavior can lead to long-term profitability through increased trust, customer loyalty, and reduced legal risks. Incentive programs, develop incentive programs that reward ethical behavior and compliance with ethical standards. Corporate social responsibility, CSR. CSR initiatives, incorporate ethical AI practices into broader CSR initiatives, highlighting the company's commitment to societal well-being. Public accountability, use public accountability measures, such as publishing annual ethics reports, to showcase ethical commitments and practices. Consumer expectations, leverage consumer expectations and demands for ethical behavior as a driving force for companies to adhere to ethical standards. Investor influence, engage with socially responsible investors who prioritize ethical practices in their investment decisions. Leadership commitment, ensure that organizational leaders are committed to ethical behavior and lead by example. Ethics officers, appoint ethics officers or committees to oversee ethical practices and address any ethical concerns. Conclusion: while profit motives and competitive pressures can pose significant challenges, education, regulation, and collaboration can still have a powerful influence on promoting ethical behavior in AI development and implementation. By aligning incentives, leveraging CSR initiatives, engaging stakeholders, and fostering ethical leadership, it is possible to create an environment where ethical considerations are prioritized alongside profit motives. The key lies in demonstrating the long-term benefits of ethical behavior and creating systems that support and enforce ethical practices.
Okay, so um, it seems that GPT-4o is quite optimistic about humans' ethics practices around the use of AI. And although the AI voice used by the model is kind of inconsistent, uh, sometimes it throws out some weird accent in French and Spanish, but overall, this seems to be a good conversational exercise. So let me know in the comments below if this format is something that you would like to see more often, and I'll see you in the next video.